Welcome again. The focus of this lesson will be to resolve vectors into horizontal and vertical components. This is an important skill I'll soon build upon for mathematically performing vector addition. You might recall that when two or more vectors are added, a resultant vector forms. The converse to this is a resultant vector may be split into component vectors. We'll look specifically at resolving vectors into horizontal and vertical components, as this is the most useful form for vector addition, which is what we are working towards. So what will this look like? So let's say we want to resolve this vector into its horizontal and vertical components, like this. The horizontal and vertical directions are perpendicular to each other. As a result, a right angle triangle forms. As a result, we can use our cosine and sine trigonometric ratios to determine the magnitude of the vertical and horizontal components. So cosine theta is adjacent over hypotenuse, which means that the magnitude of our horizontal component, our adjacent side, will be h cosine theta, like this. Similarly, sine theta is opposite over hypotenuse, which means that the magnitude of the vertical component will be h sine theta. Now, just as a reminder, make sure that you check the units that you're working in. If the question gives you your angle in radians, make sure that your calculator is in radians. And if it gives you it in degrees, make sure that you're working in degrees. Now, one thing which I'd like to point out is h cosine theta won't always give you the horizontal component. So to the left, I have got the setup as I have just constructed it before, but to the right, I have constructed the setup differently, with the vertical component first, then the horizontal component. So make sure that you check your diagram as to work out what's going to be the cosine, what's going to be the sine. One thing that a trick that I use to make sure I get it right is remember that cosine theta, that is in terms of the adjacent side over the hypotenuse, which means that cosine theta is relative to the adjacent side. So the adjacent side to the angle in question will have a cosine on it. So if we look in the first example, as I had previously constructed it, h cosine theta is the side which is next to the angle. Whereas in the second, if I was to construct it the other way, the second example of it, h cosine, I'm writing as 90 minus theta because in this case we know that's the angle, but just assume that it's an angle in its own right. H cosine an angle, or theta 2 we'll call it, h cosine theta 2, that's adjacent to the angle. So as a result, it's going to be the cosine of it. And similarly, if it has anything to do with the opposite side, so for the opposite, it'll be h sine theta. And you can see that that is true of both of these examples. Just something to keep in mind. Now let's have a look at this example. We have a 5 Newton vector, and we're trying to resolve that into its horizontal and vertical components. So you can clearly see that the horizontal component should be 5 cosine 45 degrees and the vertical component 5 sine 45 degrees. And we can check that we're doing it right, as cosine theta is the adjacent over the hypotenuse, which means, okay, adjacent, that must have something to do with cosine. So it has to be h cosine theta, 5 cosine 45 degrees. Which means that for our vector, the horizontal component's 5 cosine 45 degrees, which is 3.54 newtons to the right. And then our sine theta ratio is sine theta is opposite over hypotenuse. We know that the opposite side has something to do with sine theta. So our vertical component must be 5 sine 45 degrees, or in its general form, h sine theta. So just keep in mind that It's sine, so it has to do with the opposite side. Or because we're working with the opposite side, we know it has to do with sine. So yeah, the vertical component will be 5 sine 45 degrees, which is 3.54 newtons upwards. Let's have a look at this example. We are resolving this 20 Newton vector, and it's acting in a 30 degree angle. So the horizontal component, the vertical component will be 20 sine 30 degrees. Sine, because we're working with the opposite angle. I was saying sine theta is opposite over hypotenuse, so the opposite side, that has something to do with sine. It's going to be 10 newtons upwards. And the horizontal component, that has something to do with cosine, because cosine theta is adjacent over hypotenuse. We have adjacent in that, which means that the adjacent is h cosine theta 20 cosine 30 degrees, which is 17.32 newtons to the left. Thus, to conclude, a vector can be resolved into horizontal, or can be resolved into any two or more components, but for the purpose of vector addition, it's useful to resolve into horizontal and vertical components. And trigonometry can be used to resolve vectors into perpendicular components, or in this case, horizontal and vertical components. Up next, I'm going to do a few examples of vector addition using the skill that we have learnt today. In the meantime, thanks for watching, and please feel free to subscribe.